Hey math fans, we're on section 5.4.2. Let's get started. Today we're going to be taking a look at squares inscribed in circles. Triangles are not the only figures that can be inscribed in a circle. Remember, a square is a four-sided polygon, and it's also regular, meaning that all the sides and angles are going to be congruent. In fact, each angle is going to measure 90 degrees. First thing we're going to do is pick a point. We'll label it X. And then choosing a reasonable radius, we're going to take our compass and draw a circle with the center of X. Next, we're going to choose any point on the circle, label it point A. Using our straight edge, we're going to construct a line segment that goes through X, which is the center, to some point C on the opposite end of the circle. Yes, that is called a diameter. Next, we're going to construct a perpendicular bisector of the diameter. And if you remember the first step in constructing a perpendicular bisector to a line segment, we have to choose a distance that's more than halfway. From point A, we're going to construct an arc. Then switching centers, we're going to put the sharp point of our compass on point C, draw another arc. Now we have to be careful in this next step. We have to look, where are the arcs intersecting? I've highlighted where the arcs are intersecting, and notice how close they are to where the circle is. Now this really depends on how big you made your radius. Maybe your arcs will be intersecting outside the circle, and then sometimes it might even intersect on the circle. What we're going to do now is draw a line through the intersections of both of the arcs. Now this is where it gets tricky. We drew a line through the intersection of the arcs, but now I want you to ignore the intersection of the arcs. What we are looking for is, where does the line intersect the circle? That's where we're going to put B and D. Notice I've highlighted where the circle intersects the line. I've labeled this point D, and then on the opposite side, we'll label it point B. Once again, double check, are all the points A, B, C, and D on the circle? If they're not, you're not going to end up with a square. Next, we're going to draw a line segment from A to B, B to C, C to D, and finally A to D. And now we can conclude we have a square ABCD with right angles at A, B, C, and D. And all the line segments, AB will be congruent to BC, which will be congruent to CD, which will be congruent to AD. Here are some common misconceptions. The number one mistake I see people make is they put the actual point of the square on the intersection of the arcs, and you will get this picture right here, which is not a square. So just be careful. Make sure that all of the vertices are on the circle. And that's going to do it for this section. We'll see you in class.